Hello, John from Fuzzy Labs here. Have you ever felt frustrated when playing a simple card game? Well, why not cheat using machine learning? If you've seen our previous videos, then you'll know what we're up to. But for the benefit of those who haven't, here at Fuzzy Labs, we're taking part in ZML's month of MLOps competition. The goal is to create a production grade MLOps pipeline using ZML. As we're all at Fuzzy Lab pretty terrible at card games, particularly Dobble, we're training a model that can play it. Dobble is a game you win by being the quickest to find the matching symbol on two or more cards. And to make it even more interesting, we're going to run our model on the edge. So today I'm going to talk a little bit about the data science part of this challenge. The first step for us was to create a labeled data set. So there are 57 different symbols that can appear on a Dobble card, with each card having 8 unique symbols. For example, zebras and trees. We used an existing data set of Dobble card images and then manually drew bounding boxes around every single symbol on every single card. It was a team effort, but we're not going to talk about how difficult it is to do this using trackpads. Once we had a fully labeled data set, we could then start to think about our overall approach and what we needed to do. So what we did was we took a user-centric approach and imagined someone placing 2 Dobble cards on a desk with a camera looking at them. We knew that we'd need to identify and isolate each card and then pass that to the model and then get back a set of symbols where we could find the matching pair. To isolate the cards, we don't really need any machine learning to do this. We can do it with standard computer vision techniques. But what we did know is that we would want to train an object recognition model. To do that, we knew the data would need to be in a different format, as the model needs the images as well as bounding boxes and labels for each of the symbols on the card. So we packaged our data up into a format called visual object classes. We go into more detail about this in the blog post. Now that we had the data and the approach in place, we started to think about the model itself. The model needed to detect, locate, and classify each symbol on the Dobble card in real time and against a video feed. So what did we do? We used a single shot multi-box detector known as SSD. We jump-started our training process by using MobileNet V1 as a backbone model. And as we're also deploying to the edge, where there are a limited number of on-device resources, and with MobileNet V1 designed specifically for edge and mobile environments, we thought that this would be a sensible choice. We wanted to produce a model that performs well and is optimized to our specific problem. So this is where ZenML comes into its own. What it did was it allowed us to easily configure various training and evaluation runs without needing to modify any of the underlying code whatsoever. And as training is compute intensive, we wanted to use the cloud to scale up resources at the training time. So ZenML stack recipes allowed us to do this and allowed us to deploy a full MLOps stack in minutes rather than in hours to the cloud. So this was a whistle-stop tour of the data science in our solution and how ZenML helped us. Check out the blog post link to in this post and keep an eye out for our next post where we're going to talk about the entire pipeline that we created for our solution.